Good day everyone, my name is Graphics. In this video, we want to solve a problem involving mechanics. I'll be looking at an aspect of statics which is called frame structure or also known as what? Trusses. And the question goes like this. It says, a cantilever brace truss supported on rollers at E and hinged at A is loaded as shown in the figure above. Determine the forces in the members of the trusses, also determine the reaction at A and E. Now, if you look at the figure above, this is what we have. It says it is hinged at A. This is what we call the hinge support, this symbol you're seeing here. And it is roller at E. This is what we call the roller support, what you're seeing here. And we are told to find the forces in each member, right? Member A, B, this member here, member what? BC, this member here, member DC, and member what? ED, right? Because a frame structure is a multi-force member. It comprises of different members that makes what? That structure. So these are the structures that we have here, right? And we have two forces acting at point D downward, right? Another force at point C downward, and their magnitude is what? 5 kilonewton. Is that okay now? Now the distance from E to D is 2 meter and D to C is 2 meter. Likewise from A to E is also what? 2 meter. Now the first thing you have to do is to draw your what? Your free body diagram, right? Now if I draw my free body diagram, I'll be having this, the force acting at A, the hinge support, this is hinge support, it will be having two reaction, right? So the support, when you convert it, you'll be having two reaction. So this is what we have here in this direction and in this direction, right? Now, if you look at the other support here, which is the roller support, it will be having what? One reaction. It can only go in the vertical plane, upward and what? Downward. So you allow the arrow point in the direction that it is not moving to. You can either point right or point left, depending on what you actually want. By the time you are done solving your question, it will tell you if your direction is correct or is not, right? Now, similarly in the hinge support too, you cannot move in any direction. That is why I'm taking two X and Y, right? Either it is facing up or facing down, or either it is facing left or facing right. Once you are wrong with the direction you've taken, at the end of your question, the solution, you see that the direction you took is not the right direction. So this is what we have as our free body diagram, right? So we'll call this reaction acting upward, we'll call it our RAY, meaning reaction at point A along y-axis. We'll call this our RAX, meaning reaction at A along x-axis. We'll call this our REX, meaning reaction at point E along x-axis, right? So that's what we have. Now, the first thing we will do, according to the question, is that we should calculate for what? For the reactions. That is the first thing you do in any question involving trusses or frame structure. The first thing you have to do is calculate for what? The reaction. So we have reaction at point A and E. So we're calculating for the reaction at point A and E. And we're going to be using the conditions for equilibrium. And we know we have three conditions for equilibrium. We have the summation of all the horizontal components equals to 0, that is f of x. We have the summation of all the vertical components equals to 0, that is f of y. And we have the moment about a point equals to 0, right? That's what we have there. So when you say summation of f of x equals to 0, it means all forces acting towards the left must be equals to what? All the forces acting towards the right, right? So when you say summation of what? F of y or horizontal vertical component, means all the upward force is equals to what? All the downward force, right? And when you talk about the moment and take summation of moment about a point, it means that is equals to 0. It means that all the clockwise moment acting is equals to what? The anti-clockwise moment. Now we move forward. Now first take the first one, which is what? Summation of what? F of x equals to 0, or you can say summation of h equals to 0, depending on what you want to use. They are all the same thing. The h there stands for what? Horizontal component. The f of x also stands for what? Horizontal component, or you say that what? Forces acting along x-axis. And when I do that, you now consider the forces acting towards the right to be positive and the forces acting towards the left to be what? Negative. This is what we have. That is my condition there. So if you look at the horizontal component here, I'm having ROEX is horizontal because it is lying along the x-axis, so I'll consider it, plus my ROAX. ROAX is also acting along the x-axis. So these are the only forces we have here acting along x-axis, right? No any other force is there acting along x-axis. Now equals to what? 0. So I'll term that my what? Equation what? Equation 1. Then the next thing I'm going to do, the second condition for equilibrium that says that what? The upward force is equals to what? Downward force, which is giving us summation of f of y equals to what? 0, or you can say that summation of v equals to 0. That v stands for what? Vertical component, and the f of y stands for what? Forces acting along y-axis, right? They are both the same thing. Now you now consider your upward force to be equals to positive and your downward force to be negative, right? Now let's start. Now if you look at arrow AY here is acting upward, so it will be positive according to our condition. Now if you look at your 5 kilonewton here is acting downward, so we'll call it -5 because acting downward. The next one here, -5, also acting downward, equals to what? 0. Now if you -5 will give us -10. So my ROAY minus -10 is equals to what? 0. So my ROAY will be equals to what? 10 kilonewton. That means when the -10 go to the other side of the equation sign, to turn to what? Positive. So that we're having that, right? Now the third condition for equilibrium is the summation of moments about any point you choose here, but I like taking about my hinge support here. So the summation of moment about point A equals to 0. Now I'm going to consider my clockwise moment to be positive and my anti-clockwise moment to be what? Negative, right? So let's start. And we know what moment is. We say moment is the product of force and what? Perpendicular distance, right? From the point of action to the line of action of the force. Now, if you don't really know how to calculate for moment, you can just click on this link at the top right corner of the screen. It will show you on how to calculate for moment of any given figure or a body, right? So let's start. Now in this question here, we are considering point D. There's a force acting at point D. So if I should take moment at point A, it means any force at point A will not be considered. We assume there's no force acting at point A. So all other force will be acting towards point A. For instance, if I take the point D acting downward, the moment it says it will be going towards what? Point A in this manner, going to the direction of what? Of point A, right? And when we look at that, that is what? That is clockwise. From B to D, this force here, right, is perpendicular to this distance here. Are we good now? This force D here at point D is perpendicular to what? To this distance here. So what I will do is it will be going towards what? Towards point what? Point A. So we're having 2, that is 5 times 2, right? Plus this other force here we have here is also acting towards what? Towards point A. Is that again? Is acting towards point A. So it will be what? Also 5 times what? 5 times 4. Distance from here to here, which is what? 4. Are we together here? Now the next thing we are going to be doing here, if you do that 5 times 4, then the next one will be arrow EX. Look at the arrow going towards what? Towards point A, right? The arrow is going towards what? Towards point A, and it's going anti-clockwise, so it will be negative arrow EX multiplied by the distance from E to A, and that will give us what? That will give us 2, all equals to what? 0. So 5 times 2 is giving us 10, plus 5 times 4 is giving us 20, minus REX times 2 give you minus 2 REX equals to what? 0. Now, if you do that, 10 plus 20 is 30 equals to minus what? 2rex. Now if I take the negative 2rex to the other side, it will give us positive. So we have 30 is equals to 2rex. And making rex the surrogate of the formula, my res will now be equals to 30 over 2. So rex here is equals to what? 15 kilonewton, right? Now we'll be substituting res into equation 1 above, right? And this is my equation 1 here that says that what? Rax plus rex is equals to 0, right? Now if I input my rex in this equation, I'll be having rax plus 15 is equals to 0. And when the 15 goes to the other side of the equal sign, my ras will be equals to minus 15 kilonewton, right? Now the ras here is giving negative 15, but in our actual diagram, ras is what? Is positive, right? So I'm going to change it just like you're seeing here now. I have changed it in this manner, right? So this will now give me will now be pointing in the negative direction to conform with my answer here. That's why I said that whenever you take an direction that is not equal to the direction that you take, you change the direction, right? Since I took a positive direction and my final answer is telling me a negative here, so I'm going to change the direction to what? Rax, going towards the negative side. Now we will now start. We calculated for our reaction successfully. The next thing is for we to calculate for what? For the members. We're going to calculate for what? For each of what? Of the members. Now, so we'll start doing that. So we say that in calculating for members in any given frame structure, there are three ways at which you can achieve that height. The first one is using your joint analysis. The second one is using your section analysis. And the third one is using your what? Your graphical method, right? But for the benefit of this video, I am going to be using what is called what? The joint analysis, right? In order to calculate for the forces acting along each member. Now, when I mean the force acting along each member is this. If you look at member AB, right, there will be forces acting at it. So I'll call it this way. This will give me FA what? FAB. And this will give us what? FBA. Remember that FAB is equals to what? FBA, right? There's a force acting there. Similarly, at joint AE, there will be a force acting in this direction here. This will give my what? My FAE and my FEA. They are both the same. Now, also at this member here, also that is a member ED, a force acting in this manner, FED, and the one acting here, which is what? FDE. Also along member AD, I'm having F what? AD and what? FDA. Now along member BD, we also have the same force acting here, FBD, and here FDB. Then along member BC, we have this FBC and what? FCB. Along member DC, we're having FDC here and what? FCD. So these are all the forces here. So right, using joint analysis, we need to consider each joint, and joint is a point where two or more members meet, right? So, and for you to take a joint, there was one thing you must put into consideration. The forces, the unknown force at that joint must not be more than what? More than 2. Right? The maximum the force the unknown member you must have the unknown force acting a member in that particular joint must be just 2 and below, right? At most 2. Is that okay now? So if I look at joint E, I'm having if I look at joint E, I'm having 2 unknown member. Let me bring out joint E so you see what I'm talking about. 2 unknown member, right? At what? At joint E. This way. So if I bring out that point, I will have this RAX acting here. Then if I remove FEA, I'll be having this. And if I bring out FED, I'll be having this, right? And this is my joint E here. Now I know the value of REX, which we calculated for one of the reaction, but I don't know the value of the magnitude of the force FEA and the magnitude of what? The force FED. So that is why this is one of the member I can take. And also, I can also take point C, joint C also, because I only have 2 unknown, which is what? FCB and what? FCD. So any of those two. I can also take joint So these are the two members I can take, right? I can't take joint B because I don't know FBC, I don't know FBA, and I don't know what FCD. Likewise, joint D also. Likewise, joint what? Joint A. So the best member I can start with is either what? E or C, right? So I'll be starting with joint E. So if you do that, look at what we have here. So we'll only be using two conditions for equilibrium in this part here. Why? The reason is that there's no distance. As when we have distance, I would say three of them, which will be summation of f of x, summation of f of y, and what? Summation of moment about a point. But because there's no distance, we're only considering a point. That's why we're only using two of the conditions, right? Which is f of x, summation of f of x, and the summation of what? F of y. So if I say that the summation of f of x is equal to 0, we will consider the forward force to be what? Positive, and the force acting backwards to be what? Negative. Now if you look at this, FED is acting in the right direction going forward, so it is what? It is positive. And REX is acting at the right direction also, it is also positive. So we say that what? REX plus FED equals to what? 0, right? Now what is the value of REX? REX from our question is given to be what? 15 kilonewton. So write 15 plus FED, which is unknown, equals to 0. So making the FED the sort of the formula, my FED will be equals to what? Minus 15 kilonewton, right? Now if you look at now, we're having the FED to be negative, and from my diagram I collected from the main diagram, it is acting positive because it's going towards the right. So I will have to change direction so that to conform with what I have here, so it will now be acting backward. So acting backward is what we have in here. That is my FED, right? Now the question is, there's something we call a tie and what? And a struct, right? When a force is acting inward in form of what? A compressed area, a push force, two forces are acting in an inward direction like this, right? You call it what? A struct or a comp. But when the force is going outward, which is a tensile force, right? You call it what? A tie. Now since I have changed the direction of this force, what do you notice? It is going into that circle, that is going back into the circle, right? Which is going back into that joint what? Joint E. So we'll call it what? We'll call it a struct because it's going in backward. That is the kind of force acting at that particular member. Now we move forward. We've gotten that to be what? Negative 15. The same thing we'll now do for summation of f of y equals to 0. We'll consider the upward force to be positive, the downward force to be negative, right? Now if you look this closely, we only have one force acting upward, and that is what? FEA. Since there's no any other force there, so mean my FEA is what? Is equal to 0. So the FEA force is having little or no effect on this what? On this structure, right? Now we move forward to the next member, next joint. So we'll now consider what? Joint what? Joint A. So I'm going accordingly, right? Joint A is the best member to consider again. Now if I rewrite that out, draw out that joint, I'll be having this. You can see that the arrow AX in this direction, right, which we've changed here, going backward. We have the arrow AY facing upward. We have the FAB one, and we have the FAD, and we have the FEA acting downward at an angle of what? 45. Why? Because this part here is what? 45 degree. So alternate angle automatically here also is what? 45 degree. That's how I got the 45 there, right, from the structure we have. Now if you look at this FAD, it is inclined, and in mechanics, whenever you see a force that is inclined, you have to what? Resolve, applying your resolution of forces to that force. So when you resolve, you are going to be having this that we have here, FAD cos 45 and FAD sin 45. Now if you don't know how I resolve to get this member, right, you can click at this link at the top right corner. It will show you on how to what? Resolve forces. Is that okay now? So you click on this link I'm pointing to on this top right corner of the screen. Now we've gotten that, so we'll now consider summation of f of s equals to 0. So we'll consider the forward force to be positive and the backward force to be what? Negative. Now if you look closely, my RAX is an horizontal force and is acting in the right, going in the left direction, right? So I'm putting what? I'm having my RAX there. Then we're having the plus FAB, right? Then we have plus, because FAB also is going forward, so I'm using positive. So the RAX you see there is what is negative. Now plus what? Plus FAD cos 45, right? This force here, FAD cos 45. So I won't be dealing with the inclined force anymore because I've already resolved the force. So that is the only horizontal component we have there. So we are going to what? Start inputting our value. We know that the value for RAX that we did is negative 15, right? Plus FAB, right? Plus FAD cos 45 equals to 0. So if I make FAB plus FAD cos 45 equals to what? 15. So I'm taking the negative 15 to the other side of the equal sign, right? So it becomes what? Positive. So I'll call that my equation 1. Now, from here, I will now consider summation of f of y, that is the second condition for equilibrium, equals to what? 0, right? So I will say the upward force to be positive and the downward force to be what? Negative. So let's see. F, my RAY is facing upward. You can see that. So the vertical component is positive. Minus FEA, you see it's facing what? Downward, so it will be negative. Minus FAD sine 45, right? It's facing what? Facing downward. FAD sine 45. So equals to what? Equals to 0. So these are the vertical components that we have here. So RAY from our question here is one of the reaction. Is given as 10. Minus FEA, we know FEA is 0, so I'll put 0 there. Minus FAD sine 45 equals to what? 0. Now, if I make my FAD sine 45 equals to 10, if I take the 10 to the other, if I take the FAD to the other side of the equal sign, it will become what? Positive, right? So FAD sine 45 is equals to what? 10. Now, making FAD the subject of the formula. So we have FAD will now give us 10 divided by sine 45, which is same as saying 10 divided by 0.7071. That is the equivalent of what? Sine 45. So FAD will be equals to what? 14.14 kilonewton. Alright, and it is positive. So if I take my diagram, FAD here is in the positive side of what? Of the force, right? It's going towards the right. Is that taken? So we say that the forces FAD is a tie because it's an outward force. It is leaving the joint. So since it's leaving the joint, it's going outward. Look at the arrow, it's leaving the joint. So it's going outward. So we'll call it what? A tie, or the force is in tension. Are we good now? Now we move forward. We will now substitute FAD equals to 14.14 kilonewton into equation what? Equation 2. And what is the value of equation 2? The equation 2 is FAB plus FAD cos 45 is equals to what? 15. So when I input my value of FAD, I'll be having FAB plus 14.14 cos 45 equals to what? 15. So FAB plus 14.14 cos 45 is giving us as what? As 10 equals to what? 15. So if I make my FAB the solid of the formula, FAB will be equals to 15 minus 10. So FAB will be equals to what? 5 kilonewton. Now what do you notice? FAB is positive. So if you take the diagram, it's still positive there. So the diagram the direction we assumed is correct. And that is leaving, is going outward, is leaving the joint, right? So we say that what? It is a tie also. Now we'll move forward to joint B. Now if you look at joint B, we have this force acting towards the left, which is FBA, or we say FAB, right? It's going towards the left. And we have another force here going downward, which is FBD. And we have another one going at an angle 45 degrees, which is FBC. So since that force is inclined, I'm going to resolve. Resolving it, I'll be having FBC cos 45 and what? FBC sine what? Sine 45. This is what we have. If you don't really understand this, you can click on this link at the top right corner of the screen and it'll tell you on how to what? How to resolve forces that are inclined. So when you do that, we will now take the first condition for equilibrium, which is summation of f of x equals to 0, and we'll consider the forces acting towards the right to be positive. We we'll look at the forces acting towards the right to be what? Also negative. Now, if you look at FBA is acting towards the left, and that is negative, plus FBC cos 45 is positive because it's going towards the right, equals to what? 0. These are the only horizontal component that we have there. So what is my FBA? To what we have there, FBA is equals to what? FAB, and that's given as what? 5 kilonewton from what we calculated earlier, right? So we now have minus 5 plus FBC cos 35 is equals to what? 0. So my FBC will now be equals to what? Making it sub formula will now be 5 over what? Cos 45. And my FBC will be equals to what? 7.0711 kilonewton. And it's positive. So it's conforming with the direction that we have here. And that is what? Going outward. That is a tie. Or we'll say a tension. So we'll do the same thing for the second condition for equilibrium, which says the summation of f of y is equal to 0. So we'll consider upward force to be positive and downward force to be what? Negative, right? So we'll do that to be, we have FBD, right? We have the what? My FBD going downward, so I'm using negative, plus FBC cos 45, right? So we have the FBC, so it's going downward, so that will be what? That will be negative. Since it is going what? It's going downward. FBC sin 45 is going what? Is going downward. Is that okay now? So when we do that, we will now have this to be minus FBD plus FBC is given as 7.0711, right? So we'll put that there, cos 45. So we have minus FBD minus what? 7.0711 cos 45. I mean sin 45 is equals to what? Is equals to what? 0. Now we'll now do that. So minus FBD minus what? Minus 5 is equals to what? Is equals to 0, right? So if I make my FBD sort of the formula, if this minus 5 is going to the other side of the equation sign, my FBD here will be equals to what? Minus 5 kilonewton, right? So if you look at that minus 5 kilonewton, it is acting, the FBD actually here is going to is going downward, right? And we're still having to is conforming with what we chose here. So it's a what? Is also a tie. It's going outward, right? So we'll call it a tie because it's negative, and what we choose here is going downward, also is negative, so we don't have to change direction. So it's also what? Also a tie. That's my FBD. Now we move forward. So going forward here, we're going to be considering joint what? Joint C. So considering joint C, we have FCD, FCB, and 5 kilonewton. Just as you can see in the diagram, right? So if you want, you resolve FCB since it's inclined. So we'll be having FCB sin 45 and FCB cos 45 in this direction here, right? So we resolve that. So in doing that, the summation of f of x will now be equal to 0. We'll consider the forces acting towards the right to be positive and the forces acting towards the left to be what? To be negative. So let's see. So FCD here will be equals to, we'll be having minus FCB cos 45, right? Just like what we have here going towards the right, and minus FCD equals to what? Equals to 0. Is that taken here now? So from here, if I make FCD, this is the formula, we know the value of FCB. FCB is given to be 7.0711 as given, we've calculated for that earlier, and minus what? Cos 45 minus FCD. So minus 7.0711 cos 45 minus FC what? D is equal to 0. So if you input this in your calculator, minus 7.0711 cos 45 is simply saying minus 5. Minus FCD is equals to what? 0, right? So FCD will now give us what? If I take this to the other side, we'll be having minus 5 kilonewton. Is that okay now? Now if you look at this closely, that will be what? That will be a tie, right? It will be what? It will be a tie because of what? The FCD is going towards the left, automatically, if you see the direction, is negative and is leaving the joint, going outward from the joint. So we'll call it what? A tie. Similarly, we'll look for the second condition for equilibrium, which says summation of f of y equals to what? 0. And if you look at that, FCB sine 45 is acting upward, so it's positive. Minus what? We have the 5 coming downward, right? Because it's going downward is what? Is 5. Minus 5 equals to 0. So if I input my value of FCB that we got earlier, right, which is given as what? 7.0711 sine 45 minus 5. So the value of that is 5, and minus 5 will give us what? 0, right? So we see that we're having 0, shows that it is what? It is balanced, right? So you can actually check if you go to point D, right? Let's just check if we're actually on track. Because when you continue, if you have 5 joints, you're allowed to calculate for just 4 joints. And if you check your joint very well here, we have how many? We have 5 joints, which is joint A, B, C, D, and E. So you're allowed to calculate for only 4 joints, right? So which I calculated for A, B, that is E, A, B, C. So I will just leave joint D, right? If I use C, E, A, D, I'll leave B alone. So you're only allowed to calculate for what? For 4 joints. If it's 6 joints, you're allowed to calculate for 5 joints. If it's 7 joints, you're allowed to calculate for what? For 6 joints, right? So that's what we are actually doing here. So I calculated for what? For 4 joints. Now the reason is this: if I say I want to calculate for joint D, the value I'll be getting will be what? 0, 0, and 0. And again, I'll be getting back the same answer I've gotten before. So there'll be repetition. So to avoid repetition, you only just have calculators for 4 joints if you have 5 joints, or you calculate for 3 joints if you have 4 joints, right? Which one I just did here. So that's what we have. So the last thing you should do is to draw a table to show all your members and forces, right? It's very important for you to draw the table. So if I draw out my table, I will have in the first column will be for the members, the second column will be for the forces in kilonewton, the third will be the type of force, if it is a tie or a struct, and so on and so forth. Now if you look at joint ED is given, that is the member ED. We have member ED, and the forces acting on it is 15, right? And the type of force there is a struct. Now if you notice it, I'm having negative what? 15. You don't have to put negative here, but the struct will tell you if it is negative or positive, so you don't have to put the sign here. So I'll just put 15 and I'll write a struct. That is all. Then EA, I will ignore EA because it is 0. So the next one is what? AD, right? So AD is given as what? We have 14.14, and that is a tie, right? AD is what? 14.14 is a tie. And AB, the magnitude there is what? AB, the magnitude for AB there is given as 5, and is also what? Is also a tie. Then the next one we have is BC. BC is given as 7.0711, is also what? A tie, like I showed you as we are solving. Then we have BD is given as what? Negative 5, right? And that will be what? The BD here is given as negative 5, and that is also what? A tie, right? Because it's going outward here, so it's a tie. And we have the CD. The CD is what? Is given as 5 kilonewton. CD is given as what? Negative 5 kilonewton, and that is also what? That is a tie also. So this is what we actually have here. So if you have actually found this video helpful, please don't forget to like, subscribe, share the video, and also comment.